Hello everyone, here is simple random sampling and other sampling methods. The first part is random sampling. Here is the definition for this part is the process of using chance to select. So we're going to select individuals, and that is from a population. We're going to use N for that part to be included in the sample, and sample is N also. And let's see what we have here. For the result of survey to be reliable, the characteristics of the individuals in the sample must be representative of characteristics of the individuals in the population. So what that means is that we're going to choose our samples, our individuals from our population. The key to obtaining a sample of a population is to let chance or randomness. So the point is that we should let chance or randomness while choosing our individuals from as a sample from population. Okay, so using chance or randomness rather than convenience. If convenience is used to obtain a sample, the results of the survey are meaningless. So just remember that you're not able to use convenience to obtain sample. So this is not correct method. On this part, we're going to discuss 4 basic sampling techniques: simple random sampling, stratified sampling, systematic sampling, and cluster. The most basic sample survey design is the first one here is simple random sampling. And what that is, sample size of N, as I said, when we use sample, we're going to show that with N, and that is from population of size here. That is also N, obtained through simple random sampling. If every possible sample of size N has an equally likely chance of occurring, so then we can call that sample simple random sample. So this means that all the individuals in the population have the same chance of being selected to be our sample. So now example number 1, suppose a study group of consists of 5 students. Here we have 5 students, and we have list of their names. 2 of these students must go to the board to demonstrate the homework problem. Okay, we have names, but instead of these, I want to make that simple when we listing all these here on this part. Instead of that, for Bob, for example, I will use B, here P. This one Mike, that is Mario, so I'm using MI. Here J, and for this one MA. So we can say that is our population, because in total we have 5 students, and we're gonna select 2 of these students as a sample to go to the board and demonstrate the homework problem. Part A lists all possible samples of size 2. So sample is of size 2. Listing those possible samples without replacement. Now listing, I want to start from left side. Now I'm choosing 2 individuals from this population. So I'm choosing the first one, B, or Bob. then Patricia, P. So choosing these two students, that is one possible sample. The other one, so BP, BMI, BJ, BMA. Listing all these. BMI, BJ, and BMA. Each one of these, we have two students. Since we have without replacement, now I don't want to have this one. Now starting from Patricia. So PMI, because on this part we don't have PMI. And PJ, PMA. Okay. Now without these two, now starting here we have Mike. So MIJ. MIMA. So Mike and Maria. Okay, now without that one, the only part that remains is JMA. So Jane and Maria. And that's it. These are list of possible samples of size 2. And how many we have? We have 10 possible samples. So on top we have 4, here 3, here 2, and that is 1. Adding all these we have 10. And another method to listing these is that, okay, to better see what's going on here. I started here from left side, Bob, and listing rest of these students here on the side, P, M, I, J, M, A. So for the first part, I'm using same color so you can see which one is for which part. Here I have 4 possible samples that I have in the first row. Then I started from this part, Patricia, and on the right side we have Mike, Jane, Maria. We have green color, and I had 3 possible samples for this part. Then after that, we started here. We have Mike, and then Jane, Maria. Okay, I use black color for these. Now for this part, we have 2. And the last one, we only had 1. So Jane, Maria. And in total, we have 4 plus 3 plus 2 plus 1. Okay, so we have 10 possible samples of size 2. Okay, then part B, comment on the likelihood of sample containing Jane and Maria. From this part, we already know that we already had one possible sample for these two. So that is the answer. We only have one possible sample, and that means 1 in 10 chance. Only one possible sample. Contains Jane and Maria, therefore there is 1 in 10 chance. Okay, next page. Obtaining a simple random sample. So the question is that how do we select the individuals in a simple random sample? So here we have steps for obtaining a simple random sample. The first one, obtain frame that lists all individuals in the population of interest. What this means, here frame is our population, so we're trying to find to have our population first, and then based on that we have to number individuals in that frame, in that population, from 1 to n. So this n is our population size. And step 2, use a random number table. In this example, we are going to use that one, this table, to be able to obtain simple random sample. We have other methods, graphing calculator, statistical software to randomly generate n numbers, where n is our sample size. Okay, so let's work on this example showing that how we can use this table to find our samples. A small community college employs 87 full-time faculty members to gain the faculty's opinions about an upcoming building project. The college president wishes to obtain a simple random sample that will consist of 9, so here we have 9 faculty members. He numbers the faculty from 1 to 87. Okay, I don't want to write that way. I don't want to have this 1 digit, 1 to 87, because here is 2 digit. It's better to have from like that, 1 to 87, because we're going to use this table and I don't want you be confused why I'm choosing 2 digits instead of 1, because you may say, okay, from 1 to up to 9, we have only 1 digit, so why are you choosing 2 digits? This is because of that, because this one is actually, this number is 0, 1. So we have that. Using table from, okay, this is from our textbook. The president closes his eyes and drops, so closing his eyes and drops his ink pen on the table. That means that we're following the steps that we had on the first page. Okay, let me show you. Okay, to let chance or randomness, you should have that rule. That's why he's dropping his pen on the table. And that points to the digit in row 19. Let's find that, row 19. And column 7. So this is 6, 7, 8, 9, 10. This column is 7. Okay. Using this position as a starting point, so this row 19 and this column 7 is a starting point, and proceeding downward, determine the numbers for the 9 faculty members who will be included in the sample. Okay, let's choose these. Okay, row 19, column 7. So this is where I should start. And also the point is that since our numbers are starting from 1 up to 87, I shouldn't repeat, and also I shouldn't accept those numbers that are larger than 87. Okay. So starting here from that part is 9. As I said, I should choose 2 digits number. So this is actually 98. So the first one we have 98, and that is greater than what I have here, 87. That's why I'm not able to accept that one. So this is not acceptable because this is greater than 87. Okay, next one. We moving downward because it's asking us downward. Next one is 85. And this is less than 87, so we can accept this. Okay, then after that, going up. Now start from those parts because we already finished these 2 columns. We have 7, 8. Now starting 9, 10. That's how I got 12. And this is between 1 and 87. So accepting that. Then it's 39. And after that, 97 is greater than 87 that they have here. Is not acceptable. 29. Here we have 0, 9. That means I have 9. 58. Here again, we have 12. As I said, we shouldn't repeat because I already have that part here. Next one, 6. Let's see how many we have. We should have 9 in total. 1, 2, 3, 4, 5, 6, 7. I need 2 more. 49. One more, 72. And that's it. This is our sample using this table. And starting from row 19, column 7. Adding what rule was here. We had 2-digit. Max, so we use columns. Seven and 8. Then after that, I used 9, columns 9 and 10. And also skip numbers that are larger than 87 or repeated. Okay, finish that one. Now, next page, number 3. Suppose you are the president of student government. You wish to conduct a survey to determine the student body's opinion regarding student services. The administration provides you with a list of the names and phone numbers of 500 registered students. So we have 500. Part A, which of the following procedures could you follow to obtain a simple random sample of 5 students? So in total here we have 508. I can say that is our population. And we want to obtain a simple random sample containing 5 students. Select all that apply. Between all these, we want to see which method we can use to obtain our sample. Okay, the first one, number the names from 1 to 508. So we're gonna have all these numbers that up to 508 because our population is that number. Let me write that is population. Use all these numbers and use a random number table, exactly what we did on the previous page, to produce 5 different 3 digits number. Why 3 digits? Because this number up to 508, this is 3 digits. That's why we have 3-digit numbers. And on the previous example, here I had 87. That's why I consider to have all these numbers 2 digits, even if I had 1, 2, up to 9. I wrote here 09 instead of 9, 06 instead of 6, but actually it's 9, and that is actually 6. What this means here on this part, we have 001 to 508. Okay, so 5 different 3-digit numbers corresponding to the names selected. It's asking if we can follow this method. Yes, this is correct because this is what exactly we did on the previous example. Now part B, list each name on a separate piece of paper. Okay, so writing their names on a separate piece of paper, place them all in a hat and pick 5. Since we're picking 5, we're not able to save names because those are in hat. That means that they have same chance of being selected. But this is also correct. We have same chance. That's how you can have part B. Then part C asks students to come to a meeting and pick 5 from those who come to the meeting. We're not able to use this one. What if some of these students were not able to come to that meeting? So it's not fair to choose our sample from only students that came to the meeting. I'm not able to have this part. Then part D, list the names in alphabetical order and take the first 5 names on the list. This is worse than that. This part D is worse than part C. That's not fair to use this. We didn't follow the rule for randomness. So the answer for part A is A and B. So these two are no. Neither of these. I mean C, D, these two parts. So neither of these give everyone the same chance of being chosen. Okay, part B. Obtain this sample using the portion of random number table. So here again we have this table. Same as what we had on the previous page, example number 2. Okay, the random number table provided in the problem statement. Start with the first column of the first row. Starting first column of the first row. So it's that one. And work down each column. Type the numbers corresponding to the students chosen. As I said, here we have max 3 digits. It's starting from 001 to 508. So it's 3 digit number max. Okay, now choosing what numbers we have. starting from the first row, first column. Now we have 3 digits. 754 is the first one. But this one is greater than 508. So this is not acceptable. And let's see how many we should have. We should have 5. Then next one is 169. So this is between 1, 508. We can accept that. 829. This is greater than 508. It's not acceptable. The next one, 805, again is greater than 508. Next one, 281. Okay, then 362. Now we have 1, 2, 3. 140. And 208. So this is our sample. Our sample is 169, 281, 362, 140, 208. Okay, I did the same method that I had on this part. Okay, I want to write what the sample was for that part too. Sample, and this part was 85, 12, 39, 29, 9, 58, 6, 49, 72. So this was the final answer for example number 2. Okay. Here we have another method is stratified sample. Okay. On the next page, here we have all these systematic sampling, cluster sampling, and here on top, simple random sample that we already did. And right on that page, I'm going to work on stratified sampling. Okay, stratified sample is obtained by separating the population into population into non-overlapping groups called strata. We're gonna call them strata, and then obtaining a simple random sample from each stratum. The individuals within each stratum should be homogeneous or similar. So it should be similar in some way. Yeah, for example, a member of Congress wishes to determine opinions regarding taxes. She divides her. Wait, here we have. She dividing. We have how many groups we have? We have 3 groups. One is here is low-income households. The other one is middle-income households and upper income. So we have 3 groups. She then takes a simple. Then after that, takes a simple random sample of household from each income class. Okay, so let's try that one, what that is. In total, I have, this is population. Here is, okay, let's write that here. It's population. I have many individuals here. I'm not sure how many. Okay, let me show you that part here. Where's that? It is stratified sampling. So this is population. Then I'm gonna divide into groups to have strata. Okay. This part we have 3 groups. The first one was a low-income households. So this is low income. Next one, middle income. And third group, upper income. So this part was strata. Then after that, she then takes a simple random sample of household from each income class. So I'm not sure how many I have here. If in case we had 10 individuals, that means that usually we're gonna have same number of individuals in each group. So if I have 10, that should be very close to what I have here. So maybe 10, 10, 10. Then from each one, okay, showing that part here. See, from each one, I'm going to choose a sample. And same number of individuals choosing from strata. Here we have 2 from the first group, another 2 from second group. Doing same thing. So 1, 2, 3. Let's say I choose 3 from each one. So this part is sample. Okay, now next method is systematic sample. Yeah, systematic sample is obtained by selecting every kid individual from the population. The first individual selected corresponds to a random number. So the first individual that we're gonna choose is randomly selected. So it's random number, and that is between 1 and k that we have here. Okay, example. Okay, I want to have another example set of that because I want to make that more simple. Let's first see what steps we have here. Steps in systematic sampling, population size known. The first one is determine the population size. What is our population size? And that is showing with n. Determine the sample size and compute n divided by n. So divide we're gonna divide what the population is, divide by sample size, and round down. So we're gonna round down to nearest integer. This value is k. So k is population size divided by sample size. Then step 4, randomly select a number between 1 and k. Call this number p. The sample will consist of the following individuals. So the first number that we're choosing is between 1 and k. So this is the first number that we have is p. The next one is p plus k. So me moving based on what k is here, p plus k. Then next one is p plus 2k, or in other words, that is p plus k plus again k. So adding k, adding k. Okay, you can see what I'm doing here. Adding k to each one. So this part, I'm rewriting it. P plus k. Then we have p plus k plus k. That's how we got p plus 2k. Three dots, then p plus let's say this one is 1, then you have 1k, 2k, 3k, then we have n minus 2, depending on what sample size is, so n minus 2k, now plus k, so this is adding all these, we have p plus n minus k. Okay, now let's see what is that one. As I said, you should move every k. First step is that choosing the first one. Okay, begins. So that begins and ends every 5th person who arrives. That means our k is 5. Beginning with third. Beginning with third. That is our p. Speaker evaluation survey to be completed and return to the end of the program. So the point is that what is k and what is p, and this is what I have here. So k is 5 and p is 3. If we write that one, so starting, because I don't know what numbers we have, but let's guess for that. So if we start from this number, let's say we have numbers. So p is 3, then after that we have 3 plus 5 is 8. Then we have 8 plus 5 is 13. 13 plus 5 is 18. You continue like that. Okay, I want to have another example for this part. Let's have another one here. Okay, for example, our population is, we have these numbers. Okay, then I want to select our sample from this part using these steps. So I use systematic sampling. So the first step, determine the population size. We already have that one. N is population size. N is 10. Then step 2, determine the sample size desired. So we're going to choose what we want to have for sample size. I'm choosing to have 3. So I want to select 3 individuals from this population. Then after that, find K. So population size divided by sample size and round down to nearest integer. That is K. The K is population size divided by sample size. 10 divided by 3. It's 3.33. Round down to nearest integer. So okay, here we have rounded to nearest integer. So that is 3. And then we should select P. So randomly select a number between 1 and K. Here is K is 3. So P is between 1 and 3. Let's choose that one. 2. So P is 2, and that is our starting point. So this is our sample. Starting point is 2. Then after that, 2 plus K is 3. Now here is 5. So 5 plus K is 3. And our sample size is 3. So we're going to stop here because we only need 3. Our sample is 2, 5, 8. Okay, then next one is cluster. Cluster sample is obtained by selecting all individuals within a randomly selected collection or group of individuals. Okay, I'm going to use this one. Here we have. This is population, the first part. Then on this part we have cluster. What that is, see what the difference is between these two is that I already have all the individuals that I already had in population size. The only difference is that here I have these 4 in one group. Then after that, these 4 in one group. And so in total, I have 6 groups here for this part. So I divided this population by 6 to have this cluster population. So both of these are population, but since we divided by 6 and to have groups, that's why we call it cluster population. Then after that, randomly selected cluster means we're gonna select let's say our sample size was 2. That's why I'm choosing 2 from this cluster population. When you're choosing from this cluster population, that means that you're choosing one of these groups. You're not able to choose this person number 1 and then number 17. You're not able to do that. When you're choosing, you should choose group 1, group 2, group 3, 4, 5, or 6. In this case, we had this group, the first one, and also the fifth one here. So we choose every individual. In the selected cluster. See, I chose all of these to have our sample from each group. Okay. The next one is convenience sample. This is a sample in which, convenience sample is a sample in which the individuals are easily obtained and not based on randomness. So this is not based on randomness. I had this part on the first page, remember? Is that... If convenience is used to obtain sample results of the survey are meaningless because we didn't follow that rule, let chance or randomness. So on this part, we don't have randomness. No, it's not based on randomness. The most popular of the many types of convenience samples are those in which the individuals in the sample are self-selected. So this is when our samples are self-selected. The individuals themselves decide to participate in the survey. So deciding to participate in the survey, we're not actually choosing them. That's why it's not based on randomness. These are also called voluntary response samples. Just keep that in mind, that they are self-selected. An example, identify the type of sampling used. Part A, to estimate the percentage of the effects any recent manufacturing by a quality control manager at Intel selects every 8 chip that comes off the assembly line starting with the third. So this is starting with third until she obtains a sample of 140 chips. What that is. This is actually, we already know what sample size is. That is our sample size. Starting point is third. So this is our P. And select every 8. So that is K. Our K is equal to 8. This means we use systematic. So the type of sampling here is systematic. And it's every a chip. Next one, Part B, a farmer divided his orchard into 50 and so divided into 50 subsections. Randomly selects 4. And samples are all the trees within 4 subsections. This is cluster. So he actually using this one. Guys, farmer divide his orchard into 50 subsections. He's not choosing them, just dividing into 50. And then randomly selects 4 from these and samples all trees within the 4 subsections. So in each group, he has 4. So it's like this. Let's say this is all trees that I have. So that is population. Then here is cluster. Population, and that is divided by, I'm not able to draw all these, but these are divided by 50. So this is, okay. This is the first one. And this is 50. So we have 50 groups here. And in each one we have 4. 1, 2, 3, 4. Okay, and the point is that okay, I have same numbers here. Randomly selects 4 and samples all the trees within the 4 subsections. So here we have, let's say, choose that one. Okay, so this part is cluster sample, or you can say randomly selected clusters. You don't need to draw these. You only need to know what type of sampling we have. So this is cluster. So the former samples all trees in each section. Part C, 24, our fitness wants to administer is its satisfaction survey to its current members. Using its membership roster, the club randomly selects 40 club members and asks them about their level of satisfaction with the club. Okay, here is the point. We have the club randomly selects 40 club members. This one is a simple random sampling. Each club member has a same chance of being selected. So simple random sampling. Has the same chance of being selected. Okay, part D is regarding download time on a certain website is administered on the internet by a market research firm to anyone who would like to take it. This is to anyone who would like to take it. So this is using voluntary response, and that is convenience. So this is convenience, and it's using voluntary response. Part E, to determine his DSL internet connection speed, he divides up the day into 4 parts. So day into 4 parts, and that is morning, midday, evening, and late night. He then measures his internet connection speed at 5 randomly selected times during each part of the day. This is stratified. Here we have this one. First he had population, then dividing each day into groups to have strata, then from each one selecting sample. So dividing into 4 parts, this is strata. Strata is 4 parts. We don't need to write this down. I only want to explain which one is a strata, and that is morning. midday, evening, and late night. Then from each point, he has 5 randomly selected time. So for this one, he's selecting 5. For example, selected times, we can have 7 a.m., 8 a.m., 9, 10, 11, just like that. So from each one, we have 5. So stratified, he takes the sample of measurements, during each of the 4 time intervals. So it's not that my sample is 7 a.m. It's like, okay, because he measures his internet connection speed at a specific time. So at 5 randomly selected time during each part of the day, let's say he decided to measure his internet connection at 7 a.m. Then after that, at 8 a.m., 9 a.m., and 10 a.m., and finally at 11 a.m. So he measures his internet connection at these times that he randomly selected. Okay, next part. This was example number 4. Okay, example number 5. The human resource department at a certain company wants to conduct a survey regarding worker morale, and okay, the department has a alphabetical list of 4,502 employees at their company and wants to conduct a systematic sample. So systematic. What that means, you should have K, P, and what sample size is. Sample size. Okay, we have to follow these steps. All these, which is for systematic sample. Part A, determine K. If the sample size of this part is given, sample size is 50. Sample size 50, and on top, population size is 4,502. Now, find K. K is population size divided by sample size. 4,502 divided by 50. That is 90.4%. round down, it's 90. Part B, determine the individuals who will be administered the survey. Now that we have K, we should choose what the starting point is. So we must pick a starting point and that should be between 1 and K. So between 1, 90, I'm choosing 15. Say 15. So this is our P. So this is P starting point. Then we survey. Okay, starting point as 15. Then after that, we have 15 plus K. So P plus K. K is 90. Adding these two, we have 105. So that is 105. That's at 15. Now 105 plus 90. So the third one is 195. Again, plus 90. So the number that we have here is 285. So we continue like this. Up to 15 plus, we have n minus 1. Okay, let me show you that one. We're going to use this part. P plus n minus 1 times K. And here in this case, n 50, so 50 minus 1 times K. So this is n 15 plus n minus 1 times K is 90. Here is 49 multiplied by 90 plus 15 is 4,425. See, this number should be less than what we have here for population size. This is 4,502, and here the final number that we got for our sample is 4,425. If this one was larger than this number, that means that you make mistake here, and that is not correct. This is our sample. And it's the final answer for part B. What we did here was that every 90% selected to obtain the sample. Okay, example number 6. Suppose a political strategist wants to get a sense of how American adults aged 18 years or older feel about healthcare and health insurance. Part A. In a political poll, what would be a good frame to use for obtaining a sample? What this means, good frame. Good frame to use for obtaining a sample. This one means find population. So find population. Good frame would be all registered voters who have voted in the past few elections, since they are more likely to vote. So we can have that one for our population. So a good frame, or our population can be this one. Would be all registered voters. Who have voted in the past. In the past few elections. Since they are more likely to vote. So this can be our population. And part B explained why simple random sampling might not guarantee that the sample has an accurate representation of registered Democrats, registered Republicans, and registered Independents. So why this simple random sampling may not guarantee. The reason can be, okay, because each individual from the frame or from our population has the same chance of being selected, and there is a possibility of one group may be under or overrepresented. That's why the simple random sampling may not guarantee. Okay, so because Okay, because the individual from the frame has the same chance of being selected. And there's a possibility that one group may be, because here we have three groups. We have Democrat, Republican, and Independent. That one group may be under or over. So despite since there's we maybe have each one of these group may be under or over represented, and that means that we're not following the rule that we had for randomness. We should have same chance of being selected. So we're not going to have that one on this board. That's why there's no guarantee. And part C, how can stratified sampling guarantee this representation? So instead of using a simple random sampling, we can use a stratified sampling to guarantee this representation. Or by using stratified sampling, the strategies can obtain a simple random sample within each political party. Okay, I want to draw this. You don't need to draw this, but I want to explain this more. So this is our population. We have all individuals here inside, and we don't know how many we have here. Then after that, we have three groups. This part is a strata. And here is sample. And our groups are Democrats, Republicans, and Independents. So what that means, depending on how many individuals we have here, we divided this population by 3. We don't know how many we have in each group, but when we selecting our sample, let's say, okay, so from each one, we selecting same number of individuals. Let's say I'm choosing 1, 2, 3, 4. 1, 2, 3, 4. Same thing for this one. That's why using this method we can guarantee this representation. Okay, we finished this part.